Allahu, 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 Allah.
Now, why is it the case that science doesn't lead to certainty? Because of the problem of induction. Science relies heavily on induction. What is induction? It's like a thinking process where you have a limited set of observations and data, and as a result of your limited observations and data, you conclude for the next observation that you have not observed, or the entire set of observations that you haven't observed. It moves from the known to the unknown. For example, if I've observed 1,000 white sheep, I may conclude the next sheep is going to be white. But is it true? Is it necessarily true? Is it 100% true? No, it's likely to be true given my observations that are limited. But I may observe a black sheep, right? So that's the problem of induction. It's probabilistic. It's not what you call definite knowledge from that point of view. It may change. You may have a future observation that contradicts previous conclusions. So let me give you a principle just for it to be in your mind. There can always be a new observation that can be at odds with our conclusions based on our limited data, based on our previous limited data. I repeat, there can always be a new observation that can be at odds with our conclusions based on our previous limited data. And that is the beauty of science, because it changes and it adapts as a result of the new observations, indirect or direct observations we have experienced. And this is why philosophers of science, Gillian Barker and Philip Kitcher, they say in their book Philosophy of Science, a New Introduction, published by Oxford, science is revisable. Hence, to talk of scientific proof is dangerous because the term fosters the idea of conclusions that are graven in stone. Now, before I move on to the final false assumption, I want to talk about just a quick note on falsification. Now, Karl Popper, he understood the problem of induction. His science, you can't prove scientific theories to be true in a philosophical sense. You can't prove scientific theories to be true in an absolute philosophical sense. You could just show that they were confirmed, but they may not be true from that point of view, from a philosophical point of view. And he felt that was a problem, and he agreed you can't solve the problem of induction. So what did he invent, if you like? He basically brought into existence this idea of falsification. He said scientific theories can't be proven to be true in an absolute way, but they can be proven to be false. The knowledge that you can have is knowledge of what theories are false. That's the knowledge that a scientist should be looking for. And he called this falsification. Now, what is falsification in a nutshell? It is the following. If a theory claims that something will be observed under certain circumstances and it is not observed, then the theory is proved false. Listen to this theory I made up earlier. Ready? All birds that die on a Friday will do so in mid-flight. Theory. Beautiful theory, yeah? All birds that die on a Friday will do so in mid-flight. How do you falsify this theory? You observe a bird that is not flying, it's on the ground, and it's walking, and it's a Friday, and it died while walking. My theory is falsified. That's falsification, okay? Now, what's very interesting is he was not entirely true, because you could have falsified theories that can be brought back to life. It's like an epistemic intellectual resuscitation. And all you need to do is change the auxiliary assumptions. That's why many academics, scientists, and the philosophers of science, they don't really take falsification 100% seriously from the point of view of being a hard Popperian. They're more soft Popperians. It's useful to have theories that are falsifiable, but it's not as simple as that, because if you tweak the assumptions, a theory that was dead can be revived. Let me give you an example. How did we discover Neptune? Does anyone know how we discovered Neptune? You don't know? I found it. I'm joking. We discovered Neptune because, orbits were like, wow, orbits are really nice and they're smooth and they're doing their thing, right? And, if we if we have another planet like Uranus, its orbit should be the same smooth, musical, cosmic dance, right? But Uranus seemed to be a bit drunk. It had a wobbly orbit, the perturbations of Uranus. It was like, woohoo, I'm a bit tipsy, yeah? So Uranus was tipsy. So the problem here is, what do? Do they now say, look, this has falsified our theories about orbits? No. They just changed the assumption. And what was the assumption? They said there's no other planets. So they changed the assumption saying, maybe there's another planet that's closer to Uranus that is affecting the orbit of Uranus. And that's how they discovered Neptune. So falsified theories at the onset can be revived as a result of tweaking your assumptions. And by tweaking those assumptions, you discover new scientific truths. And there you thought science was simple.